Welcome to the FMSP online revision. This session is for OCR FP1 and the topic we're going to be looking at is roots of polynomial equations. In the session we'll have a look at the specifications for roots of polynomials and also look at some exam questions to show you how you could answer them to gain as many marks as possible. So let's have a look at the specifications. First of all, candidates should be able to A. Use the relations between the symmetric functions of the roots of polynomial equations and the coefficients for equations of degree 2 or 3 only. Now what that actually means is that for quadratic and cubic equations we need to know about the sum and product of their roots. So in the red box this is what you need to learn. And just be aware that they're not in your formula book, so you do need to learn these relationships. So for quadratics, alpha plus beta is equal to minus b over a, and alpha beta is equal to c over a. And for cubics, sigma alpha is equal to minus b over a, sigma alpha beta is equal to c over a, and alpha beta gamma is equal to minus d over a. And secondly, it says candidates should be able to use a given substitution, a simple substitution, to obtain an equation whose roots are related in a simple way to those of the original equation. So let's now see if we can look at some questions which will pick out these points. So the first question we're looking at from January 2010 says the cubic equation 2x cubed plus 3x minus 3 has roots alpha, beta and gamma, and two parts. Firstly, we've got to use the substitution x equals u minus 1 to find a cubic equation in u with integer coefficients, so whole number coefficients. And secondly, it says hence find the value of the product alpha plus 1 times beta plus 1 times gamma plus 1. So let's just have a little look first of all at part 1. So be aware that this is the substitution that we've got to use, but in our cubic we've got x cubed, so we need to work out what u minus 1 all cubed is. So that's what I'm going to do first of all. Now you could expand the brackets longhand, but I'm just going to do it using the binomial theorem. So I'm going to have one lot of u cubed plus 3 lots of u squared times minus 1 plus 3 lots of u times minus 1 squared plus minus 1 cubed, one lot of minus 1 cubed. So these numbers you might recognise, 1, 3, 3, 1, coming from Pascal's triangle. So if we simplify that now, we have u cubed minus 3u squared plus 3u minus 1. And we now have got to substitute that in to the cubic equation at the top. So 2x cubed plus 3x minus 1 becomes 2 lots of u cubed minus 3u squared plus 3u minus 1 plus 3 lots of u minus 1 minus 3, which implies that, simplifying that now, 2u cubed minus 6u squared. We've got 2 times 3u, which is 6u, and another 3u, which is 9u. We have a minus 2, a minus 3, and another minus 3, so that is minus 8. And that now will be equal to 0. So we now have a cubic equation with integer coefficients. So if we have a look at part 2, notice that it does say hence find the values. So we are using our result in part 1. In particular, we made the substitution x equals u minus 1. So that means that u equals x plus 1. So basically, alpha plus 1, beta plus 1 and gamma plus 1 are the roots of our cubic equation. The product of the roots is equal to, remember, minus d over a for a cubic. But in our cubic, minus d will be minus 8 over a, which is 2. And so, for our particular cubic, the product of our roots is equal to 4. If we have a look at how the marks are given for a question like this, then you will get 1 mark, 1 method mark for expanding u minus 1 to the power of 3 correctly. You will get a mark for substituting in u equals x minus 1 all the way through, and then you'll get an accuracy mark for the correct cubic here. And for the 2 marks in the second part, you get 1 mark for realizing that you're going to use minus d over a for the product of the roots, and an accuracy mark for doing that correctly and getting an answer of 4. So let's now have a look at a second question. So from January 2011. So a few more marks here, 9 marks for this question. So you've got 2 quadratic equations at 2x squared minus 2x squared minus x plus 3 equals 0, which has roots alpha and beta, and another quadratic equation x squared minus px plus q equals 0, which has roots alpha plus 1 over alpha and beta plus 1 over beta. 2 parts. First of all, we've got to show that p equals 5 over 6, and in the second part we've got to find the value of q. So just be aware when we look at this equation, p is the coefficient of x, or minus p is the coefficient of x, so that has got to do with the sum of the roots, and q is the constant term, so that has got to do with the product of the roots. So just be aware of that when you sort of start the question. So if we look at the first part, so we've got to show that p equals 5 over 6. So we've got 2 quadratic equations. We'll write down information that we have about each of them separately. So we have 2x squared minus x plus 3 equals 0. So that has roots alpha and beta, such that alpha plus beta is minus b over a, so that's minus negative 1 over 2, which is a half, and alpha beta is c over a, so that's 3 over 2. And then we have a second quadratic equation, x squared minus px plus q equals 0, and that has roots alpha plus 1 over alpha and beta plus 1 over beta. So the sum of the roots minus b over a will be minus negative p over 1, which is p. So effectively what we need to do in part 1 is find the sum of the roots and show that it's equal to 5 of 6. So let's do that. Let's add these roots. So we have alpha plus 1 over alpha plus beta plus 1 over beta. So if we add them, we'll get an alpha plus beta, and we'll also get 1 over alpha plus 1 over beta. Now, the first alpha plus beta we can deal with, but we're going to need to add these fractions. So when we add the fractions, we'll take a common denominator of alpha beta. Alpha into alpha beta goes beta times, and beta into alpha beta goes alpha times. So hopefully we can add those fractions, and then what we need to do is to see that by doing that now, beta plus alpha is the same as alpha plus beta, so it's a half, and alpha beta is 3 over 2. So we now have all the information that we need. So alpha plus beta is a half, alpha plus beta is a half over here, but it's divided by 3 over 2. And a half divided by 3 over 2 is a third. So a half plus a third is 5/6. So that means that P, as we were asked to do, we've shown that P is equal to 5 over 6. So in terms of marks, you do get a mark for writing down alpha plus beta and alpha beta. You then get a mark for these roots here and adding the roots, the sum of the new roots if you like. We then get a mark for substituting in the values, and an accuracy mark at the end for showing that that is equal to 5/6. So let's have a look at part 2. So in part 2 we're asked to find the value of Q, and again remembering what we said at the beginning, Q as the constant term has got to do with the product of the roots. So we need, in part 2, we need the product of the roots. So we'll have alpha plus 1 over alpha times beta plus 1 over beta. And if we multiply those out, we'll get alpha beta plus alpha over beta plus beta over alpha plus 1 over alpha beta. Now, bits of this we should be able to sort out from part 1, because we had alpha beta is equal to 3 over 2 in part 1. We also knew that alpha plus beta was equal to a half. So that means we are happy, or should be happy, with this bit, alpha beta, and this bit will be 2/3. What we then need to do is add the fractions in the middle. So let's see if we can do that. So we're going to need to take a common denominator of, again, alpha beta, and that's going to give us an alpha squared and a beta squared on the numerator, and then we still have our 1 over alpha beta. Now this is not quite in a form which we can use at the moment, but it is something that you should have had enough practice. You should be able to write this down as alpha plus beta all squared minus 2 alpha beta. So it's a fairly standard technique that you need when you're solving roots of polynomial equations, that of course when you square alpha plus beta you get alpha squared plus beta squared plus 2 alpha beta, but we don't want the 2 alpha beta, so we'll take it away. And then we'll have, not to forget that little term there, so we have 1 over alpha beta. And now what we can do is we can substitute in, and we do have to be very careful now with our fractions. So we have a 3 over 2 there. Here we have a quarter on the top line, because alpha beta plus beta is all squared is a half squared, which is a quarter. Then we have a minus 3 for 2 alpha beta will be 3. and then on the bottom line alpha beta, which is 3 over 2, and 1 over alpha beta will invert that fraction, so that will be 2/3. So at this stage, great care with our fractions. We have a 3 over 2, and this one now will have a quarter minus 3, which is minus 12 quarters, so that's minus 11 quarters. But we're dividing it by 3 over 2, which is the same as multiplying it by 2/3, and I've put the minus sign here. And then we've still got our 2/3. Now 2/3 plus 3 over 2 we should be able to sort out, because 3 over 2 is the same as 9 over 6. 2/3 is 4 over 6, so that's 13 over 6. And now we have here, we can simplify this, and that's 11 over 6. So that's 2 over 6. So that means that Q is equal to 1/3. Because the product of the roots is 1/3, and up here we know that C is equal to Q and A was equal to 1. So we have Q is equal to 1/3. Now in terms of marks for that question, you will get a mark when you write down a correct expansion for the product of the roots. You will get a method mark and an accuracy mark for seeing that alpha squared plus beta squared is the same as the square of alpha plus beta minus 2 alpha beta. You will then get a method mark for substituting in the numbers here, so the values of alpha plus beta and alpha beta, and you'll get an accuracy mark at the end for your correct answer. So we're going to finish this video here, and all that's left for me to say is just remember that the more practice you get, the better, so do try and work through as many questions as possible.